Okay, so now we're going to talk about what we really need to do for better designing our player. We have used inheritance, and now we're at the point where we need to start talking about finite state machines. These are super useful. There's a little bit of a learning curve in using them, but the reason why they work is because they rely on polymorphism and inheritance. So when we can use these, this allows us to do a lot of things. It allows us to have different states based off of situations. So if I was thinking of an array, which was the list that we were using before, we had where we would put stuff in, and we'd think about it like here, like these are just different cubbies that we would put stuff in, and we would put it in there, and then we could access it by looking up their index numbers. So that might be 0, 1, 2, 3, 4. And we could access any item in the array. We could access the very last item in the array by looking at their dot length, because that would tell us how much, and then minusing 1. So I would say for this, if I had something in each one of these, that is a total of 5 items, that would be my dot length of that array. Okay? So we have already kind of played around with this. All right, now for doing a finite state machine, we kind of need to think in terms of a little bit of a different idea. And we're going to think of arrays as a stack. Okay. Now there's 2 different types of ways that we can do a stack. Okay. If you think of like having items that you do, like let's say plates, we put plates on a stack. This is the type of stack that we would model this for, would be a LIFO. That means the last in, first out. Okay, so that means that I would, from this stack, remove the very top item, because that would be the last one that I put. Okay, that would mean I'm removing this one right here. Okay, now the other way would be, say, people who are waiting in line at like a bank. So we have person number 1, yay, person number 2, and they're all queuing up because they want to deposit some money. Okay, this is an example of FIFO, which stands in for first in, first out. The first person in line is the one that the bank teller is going to talk to first. Hello. Okay, he's going to talk to this person first. That person's going to get done and then is going to leave, and then we're going to the next person. Okay, so these are 2 different things that we're using. Now for what we're going to do for a finite state machine, we want to think in terms of using a LIFO setup. So we want to look at what is left, what's the last thing that goes in. And the reason why we want to do this is because, let's say I am creating some type of game. Okay, I'm probably going to end up having different states. I'm going to end up having, say, a menu state. I'm going to end up having a game state. I might end up having a pause state. I might end up having an end state. Okay, and I'm going to end up bouncing from these, going back and forth. Now, if we think in this this LIFO type setup, we might start off with this start menu. Okay, and then after we make our selection, then we go to game. That is the next plate that I am doing. I'm just stacking these on top of each other. Okay, and then if I wanted to pause my game, I would pause, and then when I unpause, I would remove that item from the list. So this is a little bit of a variation on a finite state machine. It's called a push-down automata setup. But basically what we're saying is that we want to have some states that will be able to be removed from the list, and then we can add back on there. So there's some states that may permanently stay there. There's some states that will only temporarily be there, and we can remove them. So that's how we are going to build, because let's say that we end up setting up our states and we have a pause state, and then we want to remove that state, and then we want to add our end state because our player died. And then when we finish that state, we might remove this state and our game state, and we might go back to the start menu and then build the whole process again. So this is a common way that we might end up building with game menus and stuff. But if we're talking about like, hey, a player, so our player could end up having states. And if we think about it in states, it makes things a lot easier. I might have a run state. In a run state, I'm able to do stuff related to running. Maybe I want my character to bounce a little bit. I want him to move across the screen. But I am not switching things around when I'm not applying gravity for run because it only is dealing with run. But I do want to go to, say, a jump state. So that would be a state that I could transfer to. The jump state would be a state that I'm putting on a stack for my player, and it's going to be fired by, say, some type of keyboard input. Let's say the spacebar. Spacebar is pressed, and we go to the jump state. Now the jump state, I might have, now I have gravity. Gravity is only being applied on the jump state. Not the run state, it's applied on the jump state. It could maybe be applied on different states. I can create these states based off of what I need. So I say I have a jump state. Now I'm still looking at keyboard controls. Maybe if I press the space bar, I do a high jump or I do a double jump. These all could be different states that I could go to based off of what happened. So now the space bar that applied a normal jump, because I'm in the jump state, could go to a double jump, or maybe I'm doing an extra high jump, which maybe might be that I'm just applying less gravity. Okay, so this is another way that I can kind of be more specific. Now let's say that I wanted to push down, then maybe I might have a dive state. Okay, so here I'm pushing the down arrow and I go in the dive state. I can't go to the dive state from a run state. I only can go from the jump state. Maybe I could also do it from the high jump state, and I'm looking for those type of controls. But what if I want an additional state? Like I'm in the run state, but I want to be able to duck. The duck state could be something that I can't get from the jump. I can't get from the high jump, but I could get from the run state. And this might fire when I press the down arrow when I'm in the run state. So we can control how stuff moves. What you guys were doing before, being able to control the animation, you had to do some spaghetti code to go from idle to jump and then go back, then go to run instead of going back to idle. So we can avoid a lot of this by building a finite state machine around, say, our player. We could also do this around, say, our enemies. Our enemies might want to have some type of state, and I might do this for building, say, some type of AI. Okay, the AI might have a number of states, and I could design a hard AI, an easy AI, depending on my players. So finite state machines are very useful. for us to be able to do things. And really, the way that it works is because we set up with a base class that every state needs to inherit from, and we basically need to build a brain that is going to process it. So if we think about a basic state for a player or an enemy, now this could be different. Generally, they all have some type of enter function that's going to run, and this is going to give it its initial values, what we want. We have some type of exit state that is going to reset our values, put us back to where we need to be when we leave the state. And then we probably end up having an input and an update. Now these will control if we can go to a different state. So in here, I may, while I'm handling input, I press a space bar, I would want to switch that state, okay? And the update, maybe if I was jumping up in the air, I'm in the jump state, but as soon as I am on ground level, then I could switch the state back to the run state. So I could set these up and they will just work once I build a brain, okay? So usually these, this is where polymorphism comes in, because if everything is inheriting from this state, the enter, the exit, the handle input, and the update, I set it up to automatically look through those based off of situations. That's what the brain is going to do. With that, then the different states that I feed it could have different criteria of what to happen, how I want to control the player, that type of stuff, and it's going to work. So let's kind of think of what we would need for a brain. Okay, so if we have this FSM, which is basically our brain, we're going to need to be able to set some initial state that we want to start at. Now you could manually set this, you could, specifically set this, and the way that I'm actually walking through this, there's many different ways to be able to set up an FSM. We're doing a true FSM instead of doing like enumerators and stuff like that. But we do want to be able to set an initial state. We do want to be able to pull things off or pop things from the top of the stack. Top of stack. This will set our initial, at our first one on our stack. We want to be able to push things onto the top of our stack. So that's like me adding a new state. And then those I want to set up in some type of an update. Okay, so this update is going to actively look for it's going to directly call the handle input and the update of each state. So each state is going to end up doing some type of update and going to do some type of handle input. Okay, and the reason why I want to do this is because then I don't care in terms of what state I'm in. The FSM is not going to care what state it's in. It's just going to call whatever current state. It's going to update it. Whatever input, it's going to be looking for it. And so then the state itself is going to be determining what to do with that type of input or what is happening with that update. Okay? And then if we end up switching states, it's going to call the state's exit and then set the next state on the list. So we could pull and pop and do all kinds of stuff. So this is basically the brain that we want to set up. And we could set this up for the player. We could set it up in all kinds of different ways. So that's what I want to do for our character right now before we get any farther into it. So I'm just going to kind of show this and then we're going to kind of set it up. So when we create, let's say, a player, and we could have, basic player, we're giving it a position and a velocity, and then we can update our player. Now, our player will end up having that brain, that finite state machine, and we can set that initial state, and then we can, track what the current state is. In our player, we could update whatever that current state is by calling the FSM update. Now the FSM, the finite state machine, when we create it, it's going to end up having that LIFO stack. It's going to track whatever that current state is. We have a function to be able to set the initial state. We have a function to get the current state that we have, which would be the last one on the stack, last in, first out. We have a function to be able to pop something off of that stack. So if we want to remove a piece, we have the ability to push. Now this takes a little bit. We can push a state, and because we're building it like this, we have to have a state that we can push onto it. It can't be the state that we already have. And if both of those things are true, then we could choose to exit from the current state. If it's a poppable state, we could remove it from that stack. Then we can choose to check if our current state does not equal the state that we're trying to set up, then we can push that new state on there. Or if it does, then we are just setting our previous state, the one that we just unveiled when we removed that last state, to our current state, and then we can call that enter. Okay, so these functions then, we can choose to run them. So we're checking the handle input for that state. If there was a change, it's creating that new state. It's calling this function, and I don't have to create it again. I don't have to check what state I'm in based off of what I'm doing, because it's just going to be working off of this. Okay, and so that's going to build off of this state right here. So this state is really just, I need a handle to the subject of that state and if it's poppable or not. And then I have an enter, an exit, a handle input, and an update. Okay, so that's basically what we're going to do. This will take a bit to do correctly, but it will ultimately help you guys to be able to understand, like, I don't need to apply gravity in every situation. I only need to do it when I'm in the air. Okay, so if you had an enemy that was moving around, the enemy may not need to have gravity applied to it at all, because that's not a state that you wanted your enemy to have. Okay, so let's go ahead and start developing. Okay, so we're going to take the design walkthrough that we did, and we are going to duplicate this. Okay, and we're doing that so if there's any issues with us setting up the FSM, we're not messing up our original code. We're going to call this (3-2), and this is going to be FSM walkthrough. How about we just do player FSM walkthrough? And this will be a challenge because I'm not giving you guys all states, but you guys will start designing what is necessary. So I'll walk through a couple of the states, and then you guys are going to do the other states. Okay, so to start off, we want to start creating some classes. So we're going to create a state class. We're going to call it state.js. Now, I'm going to do this for every single one, okay? In here, I'm going to need to add, and I got to think in terms of the order. If I'm going to create an FSM for every single dynamic thing, then I want to have an FSM for that. I might end up doing an FSM for the dynamic creatures, and then I could choose to set the initial state. So enemies might end up having a different initial state than what the player has, and I can build my my controls and my AI for the enemies based off of what state I pass. So I'm probably going to end up putting this in the dynamic creatures, and then I can call that as needed. Okay, so this would make sense, which means if I'm going to do that, then I'm going to want to have this loaded beforehand. So we are going to want to create that state. We want to have a hold of that state before we create our dynamic creature. And then we're going to build this. So class, state. And in this case, I'm going to end up having to have a constructor. And my constructor is going to need to have a hold on whoever is being controlled by this state. So the easiest way to do that is just to pass in a control to this, we call it the subject, and we'll just pass that in. And then if it's poppable or not. Now this is useful because if we want this to be like a permanent state that we're not able to remove from, but we can always return to, we could do this. So an example of this might be you might have your enemy always have, say, a patrol state, and then if they get too close to you, then they go into an awareness state, and then you move away from them. That's going to get peeled back, and then they're always going to be in that patrol state. Okay, so we want to pass that in. So we're going to say this dot subject is the subject. This dot poppable is the poppable. Okay, and then for our states, we got all of these default functions that ultimately we're going to override when we are inheriting from these states. So I'm going to say enter, and I'm going to just add, we don't need it in there, but I want to be able to see if I have an error, like I didn't plug everything in. So I'm just going to say base enter state. Okay, and then we're going to do an exit state. Base exit state. We're going to end up having a handle input state, and this is just for handling keyboard commands or accelerometers or whatever else we need. Base input state. And then we have one more, which would be our update. Base update state. Okay, so ideally when I'm using this, I should not really be seeing these once I've actually plugged in states. Okay, so now I have a state. I'm going to need to plug in and start building my finite state machine. So let's go ahead and add that to manage that. So I'm just going to call this FSM.js. Let's create that. Now we cannot create the FSM until after we have a state because it's going to be looking for one. So our order matters. Okay. Now we come back to our FSM. FSM. Let's build a constructor for it. In this case, I don't really need anything for a constructor, but I don't need to pass it anything. But for our FSM, we do need to have a stack. We do need to know what the current state is, okay? Because that's going to switch, but this is going to do it by itself. Okay, so now we can start adding all of these methods, okay? So we need to be able to set the initial state. So we'll pass in a state to it, which means if we're doing this, we want to make sure that we're resetting the stack. And the reason why I want to do that is if I want to, my player dies and I am not restarting the game and I want to reset my player again, I can reset back to the initial state, which means I'm clearing out any state that is previously there. So I'm going to say this.stack is an empty array, okay? I want to push on top of that stack a state, and then I want to assign the current state by calling a function that we have not written yet, get current state, and then this current state is going to be, we're calling the enter. Okay. The reason why we're doing this is that we are always setting the initial values of that state that we're going to be operating on, and we're always pulling the last one on the stack, and just getting used to that instead of just always taking here. So we have that set initial state. Now we're going to need to create this get current state because we don't have anything for that yet. So I'm going to do get current state. We're going to say if this dot stack is this dot stack dot length, okay, is greater than 0. So that means I have something in my stack, then I want to return the top one or the very last one that was put in. So I'm going to return this dot stack at position this dot stack dot length -1. So that's going to be, so if I have 5 states in the stack, the last one would be at position 4, index 4. So 5 minus 1 would always give me that last one in the list. So then here, if we're looking at this, when it's called, is going to pull the top one, and that's what's going to become our current state. Now, if we don't have anything in there, we're going to need to return null because we have no state to return. So this should not return null because we have called the set initial state first, which will always have a state pushed onto it before we're getting the current state. Okay. All right. Now we need to be able to pull a state off. So I'm going to create a function I'm going to call pop state. And we're just going to say this dot stack dot pop. Okay. Any array we actually have we are able to push, we're able to pop. We can also put stuff on the front of the stack. You could do FIFO. You can pull stuff from the front of the stack. But since we're doing last in first out, this would remove the item, the last item that went onto the stack. Okay. And then this function right here, to be able to put something on there, I need to pass in a reference to the state that I want to put it in. And then I got to start asking all kinds of questions to make sure that this is done correctly. I need to make sure that the state that I'm passing in is not empty, because I'm actually going to be calling this push state all the time, and I want this to be called all the time, and if there is nothing to put in there, then it's just going to ignore and not go any farther. I also need to make sure that whatever is the state that I'm on, so the last one in my list, which would be my current state, does not equal the state that I'm trying to put on. Okay, so if I have a run state, I'm in my run state, I don't want to somehow be able to create a new run state on top of the other one. So I'm going to have it, fail elegantly. It's going to just ignore those two situations. Okay, if that's true though, I have a valid state, it's not the one that I'm currently on, then I need to call, this means that I have a different state. Okay, so let's say I'm in my run state, I want to add a jump state. That means that I need to exit out of my run state. So I'm going to call this exit that we built in our state right here. So this right here, this exit, that's what I want to call, which will reset wherever I should be in my positioning and then prepare me to be able to go into my jump state. Okay. So we want to exit out of the state. Now we also want to check if the state that we currently are on is poppable. Okay, because if it is, then I can remove it from that stack. That's what I would be calling this right here. So I can write an if, and I say if this dot current state dot poppable. If that's true, so that's just going to be a flag. If that's true, then this dot pop state. That's going to remove it from the stack, remove that last item. Okay. If it's not poppable, then I am not removing that one. Okay. That on that stack, I'm just putting another one on top of it. Okay, so I'm going off my notes. Okay, so now I need to ask if the state that I'm trying to create is, and I want to make sure, so I just exited. If I'm pulling it off, now I want to double check that the one that I just unveiled does not equal. And the best way that we can do this is to check this dot get current state. So I'm checking that very top one, dot constructor. If the constructor equals, or excuse me, does not equal whatever that state constructor is, and that's, when we're talking about a constructor, that's this right here. If those are exactly the same, that means that they are in the exact same memory location. That means I'm looking at the exact same object. Okay, so this check makes sure that I am not trying to create something that's already there. So as long as they are not the same, then it's going to be a, I can push that state on there. Okay, so I'm just going to say this dot stack dot push, and then push that state. Okay, and I'm guarding against this, that way I don't end up having, you know, multiple run states all put on top of each other. Okay, and so then after I do this, then my current state that I have for my finite state machine will be my current state. And then I can call my enter on it. So this dot current state dot enter. Could this be done differently? Absolutely. This is the way that makes sense to me for being able to create. And your guys' state machines, not for this one, but for your guys' games that you create later on, they may be completely different. The idea of this, though, the reason why it works is because we will have multiple states that are basically all using the same functions. Our FSM, our finite state machine, is going to be looking through, calling these functions, and then double checking everything. And since it's written like a very standard way, I don't have to check which update I'm looking at for which state. It's just going to be working. Okay, so that push state, that is probably the biggest piece right here. And let's make sure that I have that properly closed. Okay, so I'm just going to minimize this so we can see what we're looking at. We mentioned that we needed an initial state, get current state, a pop state, a push state. Now we need to have an update. Okay, now this update, I need to check if the handle input and the update, if those, for whatever state we're in, ever need to change, it's going to do that automatically. It's going to properly push the states or pop the states as needed. So the way that I write this is I'll say next state, which may be nothing. This may be null unless we're actually switching a state. And that's why we set up our push state to check if something is null. So we could say if this dot current state dot handle input if that is equal to something, if that's returning a value, then next state will not be null, and that will be the state that gets added. So I can say this dot push state, and I'm going to push that next state. So it will fail elegantly if there's nothing in there for next state. Now I can use that same variable and check for the update. Next state. And this is just a local variable because I don't need to hold it after this update. Next state, we'll check. So we'll just push it. If there's anything, it's going to properly apply. Otherwise, I don't care. Okay, so this is, in essence, we have built the brain of our finite state machine, and we have one state with this, okay? I want you to be able to see this working, so we're going to go to our dynamic creature, and we have the type, the position, the velocity, the dynamic versus map, dynamic versus dynamic, friendly, health, speed, and we could also pass in a finite state machine. Okay. So we don't actually need to pass in here. We can just build it. Why does that run like that? That looks silly. So I'm going to say this dot FSM equals a new FSM. Okay, and then I'm going to say that this dot FSM dot set initial state. I'm going to pass in what my state is. For right now, I'm just going to pass in that base class state. So I'll just say new state, which requires two things. It requires which the subject is. So I'm going to say this, because if we're creating a dynamic creature, a player, or enemy, they're going to be a part of this dynamic creature. So this would hold what this is. So we're passing that in, and let's say that it's not poppable because this is my initial state. Okay. Now when I call this, it's going to call the enter and do all of that stuff. Now in here, we're going to, in our update, we will call for our dynamic creature, we're going to call FSM, this dot FSM dot update. If I run this, and luckily I actually didn't make a mistake in this. See, it's showing the base input state, base update state, base input state, base update state. That's happening every frame, okay? And that is of my base states. This is now basically working. All I need to do is create some other states that will work, and those are what I'm going to set as my initial state, okay? And I can start creating for running and jumping and all of that stuff, which is going to be in the next videos, okay? So make sure that you guys have all of this put in. We need to have the base state properly created with the subject being assigned that's poppable, that we can have the enter, the exit, the handle input, and the update. And then we've got to set up our finite state machine with an empty stack, a current state. We have to set the initial state, and we got to create the get current state, the pop state, the push state, and the update, just for the FSM. Okay. Then when we create a player, we are pulling from that dynamic creature. It's automatically going to put that finite state machine in there. We could additionally pass in a specific state that we're going to be putting in for the finite state machine, but for right now, we're just doing this until we get everything more hooked up. Okay. We do not have to worry about a finite state machine going in for the coin because it does not really need that. I could probably put a simple check if the item is collected or not collected, which I could do with, say, the on interact function, okay? So work on those pieces, and then the next video we will start actually creating some states for our player, and we'll start being able to see stuff in the preview of our player working. All right, good luck, have fun.